All right, so we're doing more of the solving, and just to emphasize that we have different methods. We can factor, but in order to factor, you have to have everything set equal to 0, just like with the quadratic formula. Now, that's not going to be true when we get to completing the square, because completing the square, we're just going to basically scoot that equal sign over, leave some space here, so that we can figure out what to add, and But in my factoring method, I have to think about what multiplies to 8, or multiplies to negative 40, but adds up to negative 18. Since it's a negative 40, that would be a plus and a minus, right? There's no other way to do that. And then you can start thinking about it, and I think you're going to have to use 20 with the negative and 2 with the positive. Of course, when you set the factors equal to 0, x minus 20 equals 0, and x plus 2 equals 0, then you can solve those, and you can find your solutions to be positive 20 and negative 2. If you're doing the completing the square process, remember we talked about factoring and how this would be x minus 9, and we got that number from taking half of the negative 18. Well, what is negative 9 times negative 9? Nothing but 81. So we have to add 81 to both sides. So it literally comes down to x minus 9 quantity squared, and this side is 121. Of course, at that point, since we have a nice perfect square, we can take the square root and get x minus 9 equals 11, and x minus 9 equals negative 11. Two different equations to solve, right? You got to have one with the positive, one with the negative, and so you can add and get 20, and you can add and get negative 2. Same two solutions, right? Now, not everything factors, by the way, folks. You can complete the square with everything. You can, and since the quadratic formula comes from completing the square, you can use the quadratic formula on anything, but you can't factor everything. That doesn't always work. The test is whether the discriminant, remember step 1 of the quadratic formula, the discriminant, b squared minus 4ac, if that thing ends up being a perfect square, you can factor it. But by the time you got the discriminant and you realize it's a perfect square, you're halfway through the quadratic formula anyway. So, sometimes it seems kind of useless to go backwards and try to factor it. I mean, if you can recognize that it's factorable in the beginning, that's a whole lot easier. And so we now have the opposite of b, plus or over 2a, plus or minus the square root of 484 over 2a. So that would be a 9 plus and minus the square root of 484. Square root of 484 is 22. And so 22, which is the top value there, over 2 is 11. And oh, look, we get 20 and negative 2. Same thing we got a few seconds ago. So there's all three methods that can be used on some types. Factoring cannot always be used, but you can use completing the square and the quadratic formula on all those different types of problems. So let's do some quadratic formula stuff in application questions. Well, there's going to be times where we are going to ask you to do both completing the square and quadratic formula. Of course, completing the square is least favorite on people's list, but it's not too bad, So that's x plus 5. I'm hoping at this point you can realize that we're just going to take half of that value. Now, how do I get 5 times 5? I have to have a 25, right? And so we're going to add 25 to both sides. And so this equals 23. And then when I take the square root, I don't get a nice number, do I? I'm getting x plus 5 equals plus and minus radical 23. So kind of ugly. But then, of course, the 5 needs to go to the other side. So I've got negative 5 plus and minus radical 23. Yes, those kings can be switched as long as the plus and minus stays with the radical 23. But a lot of times you see the nice number in front of the plus and minus and then the radical afterwards. So got to push this over in order to use the quadratic formula because it must be set equal to 0. So step 1, b squared minus 4 times the a value times the c value. That's 100. Take away 8, which is 92. And then step 2 is opposite of b, right? X is equal to the opposite of b over 2a plus or minus the square root of 92, right? That's where that value came from, over 2 times a. The a value being 1, so it doesn't really change anything. So now I can start thinking about, square root 92. What perfect square goes into 92? So I'm using my calculator. Maybe I start out with 92 over 4. That does work. In fact, I get 23. So now, what is the square root of 4 over 2? Well, of course, those things cancel out. So we get negative 5 from the first part and radical 23 from the second part. And as you can see, we got to the same answer we did from completing the square. Okay. What about the next slide? Sorry if I'm going too fast. Some of this is review, so I don't want to, bog you down with this. Well, back to our rocket example. A rocket is launched from a 98-foot cliff with an initial velocity of 144. So my initial equation is h equals negative 16t squared plus 144t plus 98, which means we did something like this, okay? Where this is 98 and it's going up to a high value, right? And so we still have time here and height here, but find the time it takes to reach the rocket to reach its maximum height. Well, the strategy of opposite of b over 2a is still going to work out here to answer this part. So nothing is changing when it comes to what you're doing here, and so that would be, let's see here, negative 144. And the bottom would be negative 32, so that's 4.5 seconds, okay? Now, what happens, how do I find the maximum height? Oh yeah, that's right. I gotta plug it in, right? Plug in that 4.5. Let the calculator do the work, right? Negative 16 parenthesis 4.5 squared plus 144 parenthesis 4.5 and plus 98. So we get 422 feet. So obviously the scale on my graph, way off. So 98 is going to be more like down here, according to my picture. See if I can do this. Probably not. Okay. At what time does the rocket reach a height of 343 feet? Okay, so they give me a height of 343 feet. We know the original equation looks like this. We know that it's going to hit that because 422 is the maximum height. So it's actually going to hit it twice, right? But remember, just like we talked about, you got to get it equal to 0 before you can actually do the quadratic formula. And no, I'm not going to complete the square with this. I'm going to go straight to the quadratic formula. So I got negative 245 when I brought that negative 343 over from that side. And so now I'm ready for step 1. B squared minus 4 times the A value times the C value, okay? So now, by the way, this number should not be negative, right? Because if it was negative, that would mean that the rocket never reached that height. But we already know it reaches that height because we calculated the maximum height to be, what was it? 422 feet. Sorry, I'm trying to type and talk at the same time. And I ain't being all that successful. I got 5,056. That is probably not a perfect square. In fact, I'll just double check it just to make sure. And nope, ain't no way it's a perfect square. So we're going to step 2. X equals opposite of 144 over 2 times negative 16. Okay, plus or minus the square root of 5,056 over 2 times negative 16. Okay, so what do I get for the first part? So negative 144. Oops, why am I getting that? Okay, I see. Negative 144 over negative 32 plus or minus the square root of 5,056 all over negative 32. So I'm going to have to do this twice. Now, obviously, these two negatives cancel. 144 over 32. That's my 4.5. And then I have plus and minus, and what is this weirdo decimal over here? So if I take the square root of 5,056 and I divide that by negative 32, I get negative 2.222. Blah, 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 blah. It keeps going. All right. I'm going to take that 4.5. So I have 4.5 plus that thing. Okay. If I do the plus, I get 2.28 seconds. So that must be on the way up, I think. We'll see. And then if I do 4.5 minus that negative 2.222, blah, 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 I get 6.72 seconds. So that's on the way down. So once on the way up, once on the way down. So let me back up and show you that process again. First, what are you doing, formative? Stop this. Making me look bad. So first, we took the 343 in the problem and we plugged it in for the height. Then we realized we wanted it to be set equal to 0, so we shoved the 343 over, and then we started the quadratic formula process. It's just that the numbers were not nice, so we got ugly results. That's what happens all the time. So, just to show you that, let's go to our next slide. So when does it land on the ground? What is this thing? Ugh. All right. What time does it land on the ground? So the ground, we remember that's the height of 0, right? So that actually means that I start out with, I don't have that extra step of having to move that 343 over to the other side. I can go straight to the quadratic formula because it is set equal to 0. So b squared minus 4 times a times c equals, just typing on my calculator here, 27,008. Okay, so step 2 is opposite of b, x equals, or I guess I shouldn't, instead of saying x, I should probably say t, just because it is time, over 2 times negative 16 plus or minus square root of 27,008 all over 2 times negative 16, which this is the 4.5 plus or minus. Now the square root of 27,008 is 164.34, 164.341 approximately, all over negative 32. So we're going to do the plus and the minus. If I do the, let's take that, divide by negative 32. So that's really like 4.5 plus and minus negative 5.136. So 4.5 minus that. 4.5 minus the answer there is, so one of your answers is 9.64 seconds, and 4.5 plus negative 5.136 is negative 0.64 seconds. Now wait a second. How can you have a negative time? That would be before the object was launched. That's right, folks. Remember the picture that we had? How it went up and it came back down? The reality is of a parabola, mathematically speaking, the parabola keeps going on forever and ever and ever. But you know that does not, the entire graph does not apply to this situation. Only that part in quadrant 1 applies to this situation. So this answer over here, which was negative, is useless to me. The only actual answer is 9.64 seconds. So we toss the one that makes no sense whatsoever. So that's the end of our notes for today. I hope you understand why we tossed that answer and only had one answer to the question. Talk to you later.